Hi folks, today we are going to give life to another car radio panel that uses a driver with a reference SC75823. It was necessary to cover the LEDs to attenuate the brightness of the panel because they are powered simultaneously with the backlight and have an intense brightness that bar the capture of the video. As usual, the connection of the microcontroller goes through the data in, clock, chip enable, and the ANH pins. The identification of the pins to be connected is, as always, obtained with the aid of the multimeter to follow the driver pins to the panel connector. The power pins are direct to the LC75823 and therefore must be 5 volts DC. Certainly the regulator of the 5 volts DC is present in the body of the car radio. We apply also 5 volts DC to the backlight pin, which is also the value used to power the panel backlight and the LEDs. In addition to the keys, the panel has a quadrature button and an infrared receiver, and finally a microphone to capture the audio inside of the car. Since the burst of the 160 bits it results in the full 20 bytes, sending these 20 bytes cover all LCD segments, and the alphanumeric segments count jumps from 15 to 15, and was the digits is 14 segments, this leaving 1 bit for the predefined symbols. 11 segments are recorded according to the pattern. It's easy to send them to the LCD. As usual, I don't waste the time creating a library to make the code as simple as possible and send they bit by bit. As always, I use a button to run the code after and comment the line of the session segments to skip from segment in segment and make the relation with the number and the segment of the LCD. Of course, at the same time, we had the output in the monitor of the IDE of the Arduino. This helped a lot to proceed to the identification of the segments.